guys, Ms. Gosling here. In this video, I'm going through the Running Man lab. So this lab actually starts out with a pre-lab where you're given 5 scenarios, A, B, C, D, and E. For each scenario, you know the starting position of your person and you know their velocity. And so what you're going to do is you're going to go ahead and rank the scenarios from smallest y-intercept value to largest y-intercept value, and from shallowest slope to steepest slope. So you're going to try to use the information in this table to figure out the y-intercept and the slope for each scenario. Now, one thing to keep in mind is that this is your prediction for the lab. So I'm not going to be looking to see whether you got this correct or not, but you're going to want to think about what information you can use to figure out y-intercept and slope as you're doing this. So I put in some random predictions here. You know, you're going to want to not put in random predictions and are going to want to put in real ones. But once you've done but this should be a pretty quick task, and once you've finished making your predictions, you can go ahead and move forward to the lab itself. So for the lab, you are using the PhET Moving Man simulation, which I've linked. When you click the link, after a few moments of opening, you will see this. And what you're going to want to do is you're going to want to hit where it says Charts, go to the Charts tab. You can see I've been playing around with this a little bit. Let's go ahead and clear it so we're back to just a blank screen. So in the Charts tab, once you're in the Charts tab, you're going to run each scenario. What you can see here is what you are asked to do. And for each scenario, what you're going to want to mark down is your y-intercept and your slope. So let's start with scenario A. What I'll do is I will put in my starting position and my velocity in the simulation. So my starting position for scenario A is 0, and my starting velocity for this scenario is also 0. Then I'll hit play, and I'll let it run for a little bit. And you can tell already what your y-intercept value is by looking at your graph, and that's going to be where the line on your position time graph intersects with the y-axis. You can also tell your slope from the graph, and that of course is going to be your rise over your run, your change in position over your change in time. So I've done that for scenario A. I'm going to do the same thing for scenario B. I'll hit clear, and then I can go back to my lab and I can put in my starting position and velocity for scenario B. So my starting position for scenario B is 0, and my velocity for scenario B is 1 meter per second, and I'll hit play again. And again, looking at my position time graph here, I can read off the graph my y-intercept, which is going to be 0 here, and I can calculate my slope. So once you've run each scenario, what you should know is the answer to questions 1 and 2. So you should know which scenario has the largest y-intercept and which has the smallest y-intercept. And you should also know which slope is the steepest and which is the shallowest. And so you'll be able to tell whether your predictions were correct. And so your answer to problem 1 for the y-intercept and the slope should be either yes, my predictions were correct, or no, they weren't. If they were correct, I want you to put into words how you made your predictions. What quantities from the scenarios? So what about this table did you use to make your predictions? And if you're incorrect, I want you to explain where you went wrong when you were making your predictions. So it could be, I guessed when I made my initial predictions, but now I know that X is my y-intercept. So this is the information that I would use if I was going to make my predictions again. So my goal here, guys, is I want to see that you understand what the y-intercept and the slope of a graph translate to in the real world. So once you've done that, you can go ahead to the next section, the next question, and the next question is asking you to match my graphs. So once you've finished with question 1, you should know what y-intercept and slope correlate to on a position time graph. So which one, so whether they correlate to position or velocity or something else, you should know that based off of your answer to question 1. Using that information, you're going to figure out your initial position and your slope for each of my graphs. And as you can see, some of these have different slopes, right? And you'll want to know where in the simulation you're going to put that information. So what you'll do is, for example, say I think that my initial position for question 1 is 5, and my slope is negative 1. I can go ahead and I can actually run that simulation, and we'll see how well this matches my graph. So you can see here it's not a perfect match. It doesn't start in quite the same place, but it's a place to start. And once I have, so you might have to do it a couple times, but once you have a graph that really matches mine well, what you'll do is you'll take a screenshot, and you can use that print screen button on your computer to do that. I'm using something slightly different because my print screen button doesn't work right. And you'll take a screenshot, and then you should be able to copy that screenshot and paste it right into your document. And here what I'm looking for is how close your graphs are to mine. Because again, you want to use the information from question 1 to figure out your velocity and your position, your initial position for all of my graphs. So with that, this is your introduction to the Running Man lab. Hopefully this helps answer any questions you might have. Bye guys, best of luck on the lab, happy solving.